Okay, we're going to take a look at graphing systems of inequalities, and I'm going to try and do two examples. In both the examples, we're going to take a look at inequalities that have absolute value. Um, we see here in example one that we've got this system here. It's made of two inequalities, and it says the absolute value of x is less than or equal to 4, and y is greater than 3. I'll do the absolute value of x is less than or equal to 4 in red, and I'll do this second one, y is greater than 3 in blue, and then we'll graph the final answer um, of the AND statement for the two of them. The one thing that you need to see is that this absolute value inequality here needs to be rewritten as two inequalities. And you can do that one of two ways. The first I'll write here. You need to see that this absolute value of x is less than or equal to 4 can be written as x is less than or equal to 4 and x is greater than or equal to negative 4. Similarly, the exact same thing can be written as this. Negative 4 is less than or equal to x, which is less than or equal to 4. Now, I like to think of this one that I highlighted here, at least in my mind, because it's pretty clear that I need to graph two lines. If you see that also in the one I'm highlighting in green, wonderful. In the end, you just need to get it right. But you need to see that absolute value always will split into these two statements. Okay? So you have to be able to see that quickly. I notice here that it is an or equal to statement, so I'm going to use solid lines to make that graph. And the thing that I should see pretty quickly is that anytime I graph a statement of the form x equals number, it is going to be a vertical line. You have to have that memorized, automated, and just down at a fact level. So I'm going to graph the first line, which is going to be x is less than 4, so I'll just put a vertical line through 4. And I'll graph the next one, which is x is greater than or equal to negative 4. And I'll put some shading in. Less than 4 is going to be to the left of 4. And I'm just using little shading here so that I can make room for shading more problems than looking at an intersection. So I'm not trying to do tons of shading here, just some indicator shading, I'll call it. And here we see that I'm shading to the right because the second part of the statement says that x is greater than or equal to negative 4. Okay, from there I can just come over to the blue statement, and it is pretty straightforward. We need to see that its y is greater than 3. We're in fact going to use a dotted line for this because it's not or equal to. We can see here that it's strictly greater than. And you need to, in a similar fashion, to recognizing that x equals number is a vertical line, you need to know that y equals number is a horizontal line. And you have to be plenty automated with that. At this level, you cannot be getting that wrong. It's very easy to get backwards, but you have to do something to remember it. Okay? Now I will use a dotted line for this because, like I said, it's just greater than, not greater than or equal to. And I will draw a horizontal line intersecting the y-axis at 3. And then I will use a little more indicator shading here where we notice that it says greater than. So in relation to the line, greater than is above. Now we're just looking for where these shading indicators intersect, and we should be able to see, in fact, it's this area here. It is between the two red lines and above the blue line. So every ordered pair in this region is a solution to this AND statement. Again, it's the two statements working together. You could consider it three statements if you think of the first statement, the absolute value statement, as two statements. So let's look at this next example. I think it has absolute value in it as well, but I tried to make it a little bit different. Okay, Similarly, I'll do, the top one in red. I'll do the bottom one in blue. And you need to see immediately that the top one is in fact two statements. Okay? Now this one, because it is a greater than statement, making it an or statement, cannot be written two different ways. You need to write it just this one way, splitting it into two statements, and it will be y is greater than 3 or y is less than -3. Okay? So we see here from the symbol that it's going to be a dotted line because it's not or equal to. And we need to again see very quickly that y equals number is a horizontal line intersecting at the number. So I'm going to go get my line tool, and I'm going to make two horizontal lines, one at 3 and one at -3. Then as I look to shade this first statement, greater than 3 is going to be above it, so I'll use these little indicators to say that I'm just mentally thinking of the region above that line. And then the second statement, it is to shade the area where y is less than -3. Well, in relation to the line, less than will be below it. So I'll put those little indicators there. And again, I'm not using big strokes of shading because I'm just trying not to sort of junk up the graph, but still indicate to my mind where I'm trying to do the shading for the solution. Now, the blue line that we're going to use is going to be just a little different. We see that it has two variables, so I have to think in y equals mx plus b form. If you'd like to, you could rewrite this statement as y is greater than or equal to -1x plus 0, which will indicate that b equals 0 and m equals -1, which you then can rewrite that as -1 over 1, which means go down 1 and right 1. Okay, now, just so you know, I allow myself to write this highlighted line here because it's not a final answer. If that were a final answer, your teacher would probably take off for it because it's not simplified. But I'm just using this as a help to myself. It's not the actual answer, the graph is. And I'm just trying to strategize around the reading a little bit better. So, I will in fact go and put a dot on 0 on the y-intercept, which is the origin. Then I will go down 1 and right 1, down 1 and right 1, down 1 and right 1, and then from there, I'm also going to make note of the fact that this is an or equal to problem, so I'll use a solid line to graph it. So I will connect those dots, and I will see that the greater than symbol means to shade above the line. So I'm going to use some indicator slashes here above the line. And then I will take a step back and ask myself where I need to shade that completely. Well, I need to shade areas that both the indicators appear. And I'll try and go slowly with this. It's a little harder to see, maybe. We notice in this area, it's got red but not blue, so that doesn't count. But in this area up here, this is red and blue together. So I'll take my purple, and I will, in fact, shade that area as part of the solution. Again, we're looking for where red and blue overlap. In this area, there's nothing. And in this area, we only have blue. And in this area, we only have red. But in this area right here, we see red and blue intersect again. So I will shade that area with purple. And we will see that the solution here is actually split between two regions, but it in fact indicates all of the ordered pairs that are true for both statements. Again, the top statement being a melding of these two simpler statements. So, some keys here. You have to be very careful with absolute value. When we split it, the trick in splitting it is we make two statements. Okay? I'll review this in both problems. We notice that the first statement is, in fact, very similar to the given one. It just has the bars dropped. And in the second statement, we see that we flip the symbol over and change the sign of the number to negative. If you notice that in the original problem, I did exactly that. The first part of the statement was the exact problem with the bars drop. And in this second statement, we see that the symbol was flipped from less to greater, and the number was changed to negative. A little more memorization needs to be done around which word we use. Less than is going to give you an and statement, and greater than will give you an or statement. The last thing I'll make note of that I try to put some memorization around that, is just the word gola. Greater indicates that you will split it into an or statement, and less indicates that you will split it into an and statement. So I hope this was a help. Feel free to rewatch it. You are responsible for this material, and best of luck with it.